Okay, next we're going to talk about transformations of functions. So we're just going to become familiar with some parent functions. So these are functions that we kind of model transformations off of. First we have just a linear function, y equals x. We kind of just talk about this because it's the reflection over the inverse function. Just to be familiar, our domain is going all the way to the left, all the way to the right. The domain is negative infinity to infinity. Same thing with the range, going all the way down, all the way up. It's considered odd because it's symmetric over the origin. Think O for odd, O for origin. And if we had a diagonal line going this way, it would be symmetric over that line. That line passes the origin, symmetric over the origin. It's also 1-to-1 because it passes the vertical line test and the horizontal line test. If we drew any sort of vertical or horizontal line, it would only hit the function once, no matter where we drew it. Okay, next up is the quadratic function, another type of parent function, y equals x squared. It's just a U shape over the vertex here, passes through the origin. So all the way to the left, it goes all the way to the right. Domain is negative infinity to infinity. The furthest down we have is 0, so the range is 0 to infinity. It's even because it's symmetric over the y-axis, and it's not considered 1-to-1 because it would not pass the horizontal line test. If we drew a horizontal line, it would hit it twice, so not 1-to-1. A cubic function, y equals x cubed, looks something like this. All the way down, all the way up, all the way left, all the way right. Both the domain and the range are negative infinity to infinity. It is, again, considered odd because it is symmetric over this line through the origin, the diagonal line through the origin. Odd, think symmetric over the origin. And it is 1-to-1 because it passes vertical and horizontal line test. We have the absolute value function, which is basically just making any input positive. Looks like a V where its vertex is also over the origin, so the domain is negative infinity to infinity, the range is 0 to infinity. It is even because it is symmetric over the y-axis, and it is not 1-to-1 because it would not pass the horizontal line test. Last but not least, we have a radical function, so the square root of x, another type of parent function that we see. Domain is from 0 to infinity, and range is from 0 to infinity. It's neither even or odd. It's not symmetric about the y-axis or the origin, and it is 1-to-1. It passes both of those vertical and horizontal line tests. Okay, just stuff to be familiar with. You could always just type them into the calculator and know the rules and stuff. Okay, so we have 4 types of transformations of functions: dilations, reflections, translations, rotations. I'm sure we've seen some of this stuff in previous courses. Okay, so given this parent function, y equals x squared, looks like this guy. What would y equals f of x plus 3 look like? So if we have a plus 3 at the end of the function, that is a type of vertical shift. It's going to be shifting it up 3 units. So we're taking the parent function and shifting it up 3 units. Okay, so for our next function, let me change this color. We have minus 5 at the end. That is a shift down 5 units. So we're taking the parent function and shifting it down 5 units. So if we have a plus or minus at the end, plus minus at end of the function, we're shifting it up or down, depending on if it's plus or minus. Okay, so for the next equations here, we have a minus 3, but this minus 3 is inside our functions. It's inside of those parentheses. So when we have a shift inside of the function, that's going to be moving it to the right 3 units. You might think the opposite because, like, if we were shifting left or right, You might think it would go left because the left is the more negative side, but it's kind of the opposite of what you would expect. So a minus inside the function makes it go right 3. So then, therefore, a plus inside of the function makes it go left 5. So if the plus or minus is inside, so last time we saw it at the end, now if the plus or minus is inside, it goes left or right. And if it goes left, it is positive. If it goes right, it's negative. A little bit of the opposite of what we would expect. Okay, so these are just kind of the rules written out if you want to refer to them, but we just talked about them. Okay, so now they're giving us the parent function x squared. What would negative f of x look like? So that is y equals negative, x squared. What would that look like? So if we have a negative in front of our function, that is a reflection over the x-axis. So it's a vertical reflection. It's just a reflection over the x-axis if we have a negative in front of our function. Okay, so now they're asking if we had a negative inside our function. So that would be like if we had y equals, our parent function's x squared. I don't know why I wrote a square root. X squared. So that would be if we had negative x squared. Okay, so here's this one, here's this one. So the negative is inside the function now. So the negative's being squared. This would be a reflection over the y-axis. So difference here is the reflections over the y when it's inside and it's over the x when it's outside. Okay, so let's go back to our first one, reflection over the x-axis. So remember, this is our parent picture here. Reflection over the x-axis would look something like this, and a reflection over the y-axis, well, our parent function is symmetric about the y-axis, so a reflection over the y-axis wouldn't really change the picture much because it's symmetric, but we still have to know our rules, but this function kind of still looks the same. Okay. Now we have the parent function square root of x. So if we had a negative in front of this function, that's like the negative square root of x. This is a reflection over the x-axis. Negative is in front. So here's like a little sketch of our parent function. So it would now go over the x-axis, look something like this. Here the negative is inside of the function. So that would be if we had the square root of negative x. That's a reflection over the y-axis. So here's our function reflected over the y-axis. Okay, good to be familiar with this. And here we just have the rules written down for us. Okay, so if we're given the function f of x equals sine of x, what would the graph of y equals 3f of x and y equals y equals f of 2x look like? Okay, so first let's look at our function y equals 3f of x. So this is y equals 3 sine x. Okay, so I drew a little sketch here of the parent. So here's the parent, the original sine x. And if we multiplied a 3 at the beginning, that would be a dilation. We would be stretching our function. So that's a vertical stretch. It's going more up, more down. We're multiplying the y value by 3. It's getting taller. So instead of going to 1, remember the parent function of sine usually would go to 1 and stop there. But this one is going all the way up to 3 because we're dilating it, stretching it by 3.